You're standing on the edge of a cosmic cliff, staring into a void so vast it swallows your thoughts whole. The universe, in all its grandeur, hums with secrets, some brighter, some stranger than anything you've ever imagined. Right now, you're about to meet one of its most dazzling enigmas: quasars. These aren't just twinkling stars or lazy nebulae drifting in the night sky. No, quasars are the roaring bonfires of the cosmos, blazing with a ferocity that makes our sun look like a flickering candle. Imagine a single object outshining entire galaxies, pumping out energy so intense it could fry your spaceship's circuits from light years away. What are these celestial powerhouses, and why do they feel like they're screaming secrets from the dawn of time? Buckle up. You're about to find out. Picture this. A quasar is like the universe's ultimate rock star, stealing the spotlight in a stadium of stars. It's not just bright, it's unfathomably luminous, emitting light and radiation up to 1 trillion times brighter than the sun. To put that in perspective, if our sun is a 60-watt light bulb, a quasar is a supernova-sized spotlight that could illuminate entire galactic neighborhoods. These objects are so radiant that we can spot them from billions of light years away, meaning you're essentially peering back in time to when the universe was just a cosmic toddler. That's the first wild thing about quasars. They're time machines, letting you glimpse the universe's wild, rebellious youth. So, what's fueling this cosmic inferno? At the heart of every quasar lies a supermassive black hole, a beast millions to billions of times the mass of our sun. But here's the kicker. It's not the black hole itself that's shining. Black holes, as you know, are the ultimate cosmic vacuum cleaners, sucking in everything, even light. The brilliance comes from the chaos around it. An accretion disk, a swirling, screaming maelstrom of gas, dust, and doomed stars spiraling toward their doom. As this material gets pulled in, it heats up to millions of degrees, glowing with a fury that radiates across the electromagnetic spectrum, from radio waves to X-rays. It's like the universe is throwing a rave, and the black hole is the DJ spinning chaos into light. Now, let's pause for a second and soak in the sensory overload. Imagine the accretion disk as a cosmic whirlpool, glowing red-hot like molten lava, streaked with blues and whites where temperatures spike. You'd hear nothing in the vacuum of space, but if you could, it'd be a deafening roar, like a jet engine mixed with the crackle of a thunderstorm. The light pulses, flickers, and surges, as if the quasar is alive, breathing with raw, untamed energy. You'd feel the heat on your face, even from millions of miles away, and a strange pull in your gut, like the universe itself is daring you to come closer. It's mesmerizing, terrifying, and utterly humbling all at once. Here's a fun little thought to lighten the mood. If a quasar were in our cosmic backyard, say, where Pluto hangs out, it'd be so bright you'd need sunglasses just to check your phone. And good luck getting any sleep. Quasars don't exactly come with an off switch. Jokes aside, these objects are so powerful that they've shaped our understanding of the universe's history. Back in the 1960s, astronomers stumbled across quasars while scanning the sky with radio telescopes. At first, they thought these were just quirky stars, hence the name quasar, short for quasi-stellar radio source. But as they studied them, they realized these weren't stars at all, but cosmic beacons from the early universe, some dating back to just 1 billion years after the Big Bang. That historical tidbit leads us to a quirky detail most people don't know. Quasars are like cosmic fossils. They're most common in the early universe, when galaxies were young and their central black holes were gorging on material. Today, most quasars have calmed down, their black holes running low on fuel, like a rock star past their prime. But here's the weird part. Some quasars can turn off and turn on again if their host galaxy collides with another, dumping fresh gas into the black hole's maw. It's like the universe hitting the reset button on a burned-out celebrity, giving them one last encore. Now, let's stir the pot with a bit of academic debate. What exactly powers the insane energy output of quasars? The accretion disk model is the leading theory, but some physicists argue there could be more exotic mechanisms at play. Perhaps jets of plasma shooting out at nearly the speed of light, or even hypothetical processes involving dark matter annihilation. The jury's still out, and every new quasar we discover adds fuel to the debate. It's a reminder that even in a universe we've studied for centuries, there's always room for a plot twist. Let's zoom out and think about what quasars mean for you, standing on this pale blue dot. These objects aren't just scientific curiosities. They're a testament to the universe's sheer audacity. They challenge your sense of scale, forcing you to grapple with distances and energies so vast they make your daily worries feel like cosmic lint. A single quasar can outshine 1,000 galaxies, yet it's just a speck in the grand tapestry of the cosmos. And here's where it gets personal. The light you're seeing from a quasar left its source when Earth was still a molten rock, maybe even before life itself kicked off. You're connected to that ancient light, a witness to a story that began billions of years ago. But quasars aren't just about looking back. They're about looking forward, too. They're key to understanding how galaxies form and evolve. The supermassive black holes at their cores might seem destructive, but they also regulate star formation, like cosmic gardeners pruning their galaxies to keep them in check. Without quasars, the universe might look very different. And who knows, maybe you wouldn't be here, pondering the stars. Before we move on, let's circle back to that call to action. What do you think powers these cosmic bonfires? Is it just gravity and friction in the accretion disk? Or could there be something wilder, something we haven't even dreamed of yet? Drop your thoughts in the comments below, and let's spark a cosmic conversation. After all, quasars are proof that the universe loves a good mystery, and you're part of solving it. As you stand there, gazing into the cosmic abyss, the quasar's light feels like a challenge, a dare to keep exploring, to keep asking questions. The universe isn't just a backdrop. It's a story, and quasars are one of its most electrifying chapters. But hold on, because the cosmos has even stranger tales to tell. What happens when a black hole doesn't just bend light, but breaks every rule we thought we knew? Let's find out. You're floating in the void, weightless, with nothing but the infinite stretch of space around you. Suddenly a shadow looms, not just dark, but a darkness so profound, it feels like it's staring back. This isn't your average black hole, the kind you've heard about that gobbles up stars and bends light like a cosmic magician. No. You're face to face with the weirdest, rule-breaking black holes in the universe, ones that defy everything you thought you knew about gravity, space, and reality itself. These are the cosmic rebels, the Hoden-Kila, and they're about to blow your mind. Let's start with the basics, but don't get too comfortable. You know black holes as regions where gravity is so intense that nothing, not even light, can escape. They form when massive stars collapse or when monstrous amounts of matter pile up, creating a gravitational pit. But the universe doesn't always play by the textbook. Some black holes are so bizarre, they seem to thumb their noses at physics. Imagine a black hole so small it could fit in your pocket, yet so dense it could crush a planet, or one that spins so fast it warps space into a cosmic pretzel. These aren't science fiction. They're real, and they're out there, lurking. First up, let's talk about primordial black holes, the tiny terrors of the cosmos. Picture a black hole no bigger than an atom, but with the mass of a mountain. These hypothetical oddballs might have formed in the chaotic aftermath of the Big Bang, when pockets of space were so dense they collapsed under their own weight. Unlike their stellar cousins, which need a dying star to kickstart them, primordial black holes could be scattered everywhere, invisible gremlins zipping through the galaxy. Here's the sensory hit. Imagine a speck of darkness buzzing past you, too small to see but so heavy it tugs at your spaceship, making your stomach lurch like you're on a cosmic roller coaster. Now, shift gears to the opposite extreme. Supermassive black holes with a twist. You've heard of the giants at the centers of galaxies, like the one in our Milky Way, weighing in at millions of solar masses. But some of these behemoths are spinning at mind-boggling speeds, turning space itself into a swirling vortex. These are called Kerr black holes, named after the mathematician who worked out their physics. Picture space-time as a river, and a Kerr black hole is a whirlpool so intense it drags everything, including light, into a dizzying spiral. If you were near one, you'd feel time slow down, your watch ticking sluggishly while the universe races by. It's not just gravity. It's a cosmic funhouse where reality bends in ways you can't unsee. Here's a little cosmic humor to keep things light. If you fell into a Kerr black hole, you'd probably regret not packing a better spacesuit and a really good lawyer to sue physics for breaking its own rules. Okay, maybe not. But these spinning black holes are so wild they could, in theory, create naked singularities, points where gravity goes haywire, and the laws of physics just shrug and walk away. Don't worry, though. The universe probably has a cosmic sensor keeping those singularities under wraps. Probably. Let's ground this in a historical nugget. Black holes were first theorized in the 18th century by John Michell, who imagined dark stars so massive that light couldn't escape. Fast forward to the 20th century, and Einstein's general relativity gave us the math to understand them. But here's a quirky detail most folks miss. Some black holes might evaporate. Stephen Hawking showed that quantum effects near a black hole's edge, its event horizon, can cause it to leak energy, slowly shrinking until it pops out of existence in a tiny burst of radiation. Imagine a cosmic monster dissolving like a sugar cube in hot tea. It's a slow process, though. Small black holes might take longer than the age of the universe to vanish completely. Now, let's stir up some academic controversy. Are primordial black holes real? Or are they just a theorist's fever dream? Some scientists think they could explain dark matter, the mysterious stuff that makes up a quarter of the universe's mass. Others argue we'd have seen evidence by now, like gravitational ripples or weird effects on nearby stars. The debate rages on, with telescopes and experiments hunting for clues. It's like a cosmic detective story, and every new observation could crack the case or deepen the mystery. But wait, there's more weirdness. Ever heard of a charged black hole? These are Reissner-Nordstrom black holes, which carry an electric charge, making them even stranger. Imagine a black hole crackling with energy, its event horizon buzzing like a cosmic bug zapper. They're rare. Most black holes are neutral, but their existence hints at a universe where even the wildest ideas might be real. And then there's the hypothetical extremal black hole, balanced on the edge of physical possibility, where gravity, spin, and charge create a perfect storm of cosmic chaos. You'd feel the air, space, around it humming with tension, like the universe is holding its breath. Let's make this personal. As you float near one of these bizarre black holes, you're not just a spectator, you're part of the story. The light around you bends, creating a warped, funhouse mirror view of the stars. Your heart races as you realize you're seeing space-time itself twist and turn. These objects aren't just scientific puzzles, they're reminders that the universe is wilder than your wildest dreams. They challenge you to rethink what's possible, to imagine a reality where the rules you live by are just suggestions. And here's where it gets modern. Scientists today are using tools like the Event Horizon Telescope to snap actual pictures of black holes, or at least their shadows. The first image, released in 2019, showed the glowing ring of a supermassive black hole in the galaxy M87. It was a game changer, turning theory into reality. Now, researchers are hunting for signs of those weird black holes, primordial, spinning, or charged, using gravitational wave detectors like LIGO. Every signal they catch is like a whisper from the cosmos, telling you there's more out there than you can imagine. Before we dive deeper into the cosmic zoo, let's revisit that call to action from the Quasars. What do you think makes these black holes so strange? Are primordial black holes the key to dark matter? Or are they just cosmic ghosts? Drop your thoughts in the comments, and let's keep the conversation going. The universe is full of rule breakers, and you're helping us chase them down. As you drift away from this bizarre black hole, its shadow lingers in your mind. The universe isn't just a place, it's a puzzle. And these strange black holes are pieces that don't quite fit. But the cosmos has even weirder tricks up its sleeve. What happens when a star collapses into something denser than you can fathom? Let's find out. You're drifting through the cosmos, surrounded by a sea of stars, when something catches your eye. A faint, pulsing glow, like a lighthouse in the vast darkness. It's not a star, not a planet, but something far stranger. A neutron star. Imagine a cosmic relic so dense that a single teaspoon of its material would weigh as much as Mount Everest. These are the remnants of massive stars that went supernova, collapsing into a core so compact it defies everything you know about matter. You're about to dive into the bizarre world of neutron stars, where gravity, density, and physics itself get pushed to the absolute limit. Picture a neutron star as the universe's ultimate compression machine. It starts with a star, one that's 8 to 20 times the mass of our sun. When it runs out of fuel, it doesn't just fade away. It explodes in a supernova, one of the most violent events in the cosmos. What's left is a core so squashed that protons and electrons merge into neutrons, packed tighter than sardines in a cosmic can. The result? A sphere just 20 kilometers across, about the size of a small city, but with the mass of 1 or 2 suns. If you could stand on its surface, gravity would crush you flat in an instant, turning you into a pancake thinner than a sheet of paper. Let's soak in the sensory overload. You're hovering just above the neutron star's surface, and it's nothing like you imagined. The ground glows faintly, an eerie mix of red and blue from intense radiation. The air, if you could call it that, crackles with energy, and you feel a bone-rattling vibration from the star's rapid spin, some turning hundreds of times per second. It's like standing next to a cosmic jackhammer. The magnetic field tugs at your spacesuit, making your hair stand on end, and the pulses of light, radio waves, X-rays, sweep past like a strobe light at a galactic rave. You're not just seeing a star, you're feeling the raw power of the universe's densest object. Here's a little cosmic chuckle to keep things light. If you tried to scoop up some neutron star material for your collection, you'd need a spaceship the size of a continent just to lift it. And forget about bragging to your friends. Your sample would probably collapse into a black hole before you got home. Jokes aside, neutron stars are so extreme that they challenge our understanding of physics. Their cores might contain quark soup, a state of matter where neutrons break down into their fundamental building blocks. It's like the universe is cooking up something so exotic, even scientists aren't sure what's in the recipe. Let's anchor this with a historical fact. Neutron stars were first theorized in the 1930s by Walter Baade and Fritz Zwicky, who suggested that supernovae could leave behind super-dense cores. But it wasn't until 1967 that they were confirmed, when Jocelyn Bell Burnell discovered pulsars, neutron stars that emit beams of radiation like cosmic lighthouses. Her discovery was a game-changer, proving these objects weren't just theoretical. Now, here's a quirky detail. Some neutron stars are so dense they're nicknamed cosmic diamonds. Their outer crusts might form a crystalline structure, like a diamond lattice, but one that's 1 billion times stronger than anything on Earth. Imagine a jewel that could crush a planet. Talk about bling with a bang. Now, let's stir up some academic debate. What's really going on inside a neutron star? The outer layers are a crust of neutrons and exotic nuclei, but the core is a mystery. Some physicists think it's a sea of quarks and gluons, while others propose strange matter, a hypothetical state where particles behave like nothing we've seen. Experiments on Earth, like those at particle accelerators, try to mimic these conditions, but we're still guessing. Every pulsar signal we detect is like a postcard from the edge of physics, teasing us with clues but no clear answers. Let's make this personal. As you hover near this neutron star, you feel its gravity pulling at you, not just physically, but philosophically. These objects are the tombstones of stars, yet they're alive with energy, spinning and pulsing like they're refusing to go quietly. They remind you that even in death, the universe finds ways to create something extraordinary. You're witnessing a paradox, a dead star that's more vibrant than most living ones. The pulses hit your sensors, a rhythmic beat like a cosmic heartbeat, connecting you to an event that happened millions of years ago, when this star exploded and lit up its corner of the galaxy. In today's world, neutron stars are more than just cosmic curiosities. They're laboratories for cutting-edge science. Telescopes like the Chandra X-ray Observatory catch their high-energy emissions, while gravitational wave detectors like LIGO pick up ripples from neutron star collisions. In 2017, scientists detected the first neutron star merger, a cosmic crash that produced gold, silver, and other heavy elements. It's a reminder that the jewelry on your finger or the tech in your phone might trace its origins to a neutron star's fiery death. The universe isn't just out there, it's in you. But neutron stars aren't just about density, they're about extremes. Some, called pulsars, spin so fast they emit beams of radiation that sweep across space like a lighthouse. If Earth happens to be in the path, we detect pulses, some as regular as a metronome, others glitching unexpectedly. Imagine a star spinning faster than a blender, sending out signals so precise they rival atomic clocks. These pulses are so reliable that scientists once thought they might be alien signals. Talk about a cosmic prank. Before we move on, let's revisit that call to action. What do you think is hiding in the core of a neutron star? Quark soup, strange matter, or something we haven't even imagined? Drop your thoughts in the comments, and let's keep unraveling the universe's secrets together. Neutron stars are proof that the cosmos loves to keep us guessing. As you pull away from this pulsing, glowing relic, its rhythm lingers in your mind. The universe isn't done surprising you yet. What happens when a neutron star takes its magnetic powers to an extreme that warps reality itself? Let's find out. You're drifting through the cosmos, your spaceship humming softly, when a strange sensation hits. Like every metal object in your cabin is twitching, pulling towards something unseen. Your instruments scream warnings, and your heart skips a beat as you realize you're near a magnetar, the universe's most insane magnetic powerhouse. This isn't just a neutron star with a bad attitude. It's a cosmic monster with a magnetic field so intense it could scramble your brain, your tech, and even the fabric of space itself from millions of miles away. Buckle up, because you're about to meet the Magnetar, a celestial freak show that makes regular stars look like wallflowers. Imagine a neutron star, already denser than anything you can fathom, but now supercharged with a magnetic field 1,000,000,000,000 times stronger than Earth's. That's a magnetar. Born from the explosive death of a massive star, these beasts are rare. Only a few dozen are known in our galaxy. Their magnetic fields are so powerful, they warp the atoms around them, stretching them into bizarre shapes and making chemistry itself glitch. Picture this. You're hovering a safe distance away, because getting closer would be a very bad idea. And you feel a faint buzz in your bones, like static electricity on steroids. The magnetar's surface glows with a sickly, flickering light, pulsing with X-rays and gamma rays that could cook you faster than a microwave burrito. Let's dive into the sensory chaos. The magnetar's surface is a cracked, glowing crust, scarred from violent outbursts called starquakes. These aren't your average earthquakes. They're explosions of magnetic energy that ripple through space, sending out bursts of radiation that light up your sensors like a cosmic fireworks show. If you could hear in space, it'd sound like a mix of a screeching siren and a low, ominous hum, the kind that makes your teeth ache. The magnetic field tugs at your ship, making it groan, and you swear you see the stars around you wobble, distorted by the magnetar's grip on space-time. It's not just a star. It's a force of nature that feels alive and very, very angry. Here's a cosmic giggle to lighten the mood. If a magnetar were your neighbor, it'd wipe your phone, your credit cards, and probably your entire Netflix queue from halfway across the solar system. Talk about a bad Wi-Fi signal. But seriously, these magnetic fields are no joke. They're so strong they could disrupt the molecular bonds in your body if you got too close. Let's just say you'd be less human and more cosmic soup in no time. Let's ground this with a bit of history. Magnetars were first hypothesized in the 1990s when astronomers noticed some neutron stars were emitting bursts of gamma rays far too powerful for normal pulsars. In 1979, a massive gamma ray burst from a magnetar in a nearby galaxy hit Earth's satellites, briefly overwhelming them. A cosmic tantrum that proved these objects were real. Now, here's a quirky fact. Magnetars can cause soft gamma repeater events, where they burp out radiation in unpredictable fits. One such event in 2004 was so bright it temporarily blinded some telescopes, like the universe decided to photobomb our observations. Now, let's spark some academic debate. What creates a magnetar's insane magnetic field? The leading theory points to a dynamo effect, where the star's rapid spin and churning interior amplify its magnetism during its formation. But some physicists wonder if exotic processes, like interactions with hypothetical particles called axions, could play a role. The truth is, we're still piecing together the puzzle, and every burst from a magnetar is like a clue dropped from the edge of physics. Observatories like NASA's Swift telescope are on the hunt, but the answers remain tantalizingly out of reach. Let's make this personal. As you float near this magnetar, you're not just an observer. You're a witness to the universe's raw power. The pulses of radiation hit your ship like a cosmic drumbeat, each one a reminder of the star's violent past. You imagine the supernova that birthed it, a blast so bright it outshone its galaxy for weeks. You feel small, but not insignificant. After all, you're here, studying a phenomenon that could rewrite the laws of physics. The Magnetars' magnetic field feels like a challenge, daring you to understand it, to unravel its secrets. It's like the universe is whispering, "Catch me if you can." In today's world, Magnetars are more than just cosmic oddities. They're keys to understanding extreme physics. Their bursts help us study everything from quantum mechanics to gravitational waves. In 2020, astronomers linked a fast radio burst, a mysterious signal from deep space, to a magnetar in our own galaxy. The first time we'd pinned down a source for these cosmic flashes. It's a reminder that the universe is still full of surprises. And magnetars are like the loudest, flashiest billboards, advertising that fact. They're also a humbling nod to our place in the cosmos. Your smartphone, your car, even your planet are fragile compared to these magnetic monsters. But there's more to magnetars than raw power. Their starquakes can trigger avalanches of energy, releasing bursts that travel across light years to reach us. Some magnetars are so active, they're classified as anomalous X-ray pulsars, spinning slower than typical pulsars, but glowing with intense X-rays. Others go quiet for years, only to erupt without warning. It's like they're playing a cosmic game of hide-and-seek, and we're still learning the rules. Before we move on, let's circle back to that call to action. What do you think powers a magnetar's magnetic mayhem? Is it just a stellar dynamo? Or could there be something weirder, like exotic particles or unknown physics, at play? Drop your thoughts in the comments, and let's keep the cosmic conversation alive. Magnetars are proof the universe loves to keep us on our toes. As you steer your ship away from this magnetic beast, its pulses fade, but its presence lingers. The universe is a wild place, and magnetars are just the beginning of its strange cast of characters. What happens when clouds of gas hide secrets even wilder than these? Let's find out. You're gliding through the cosmos, your spaceship cutting through the void, like a whisper in the dark. Suddenly, a glowing haze looms ahead, vast and shimmering, like a cosmic fog rolling across an endless ocean. These aren't ordinary clouds. They're cosmic clouds, nebulae so immense they dwarf entire star systems. Some are nurseries where stars are born. Others are ghostly shrouds, hiding secrets stranger than any alien civilization. As you approach, you feel the universe shift, inviting you to uncover mysteries that make even the wildest sci-fi seem tame. Let's dive into the ethereal world of cosmic clouds, where beauty and enigma collide. Picture a nebula as a celestial canvas, painted with wisps of gas and dust stretching light years across. These clouds are made of hydrogen, helium, and traces of heavier elements, glowing with colors that would make an artist weep. Blues, pinks, and greens lit by nearby stars or violent cosmic events. Some nebulae are the wreckage of supernovae, others the birthplaces of stars, and a few are so bizarre they defy explanation. You're not just looking at a pretty space picture. You're witnessing the raw ingredients of the universe, sculpted by gravity, radiation, and time into shapes that feel alive. Let's immerse ourselves in the sensory whirlwind. You're floating inside a nebula now, and it's like swimming through a glowing dream. Tendrils of gas swirl around you, catching the light of a distant star like mist reflecting a sunrise. The air, if you could breathe it, feels cool and electric, charged with particles that make your skin tingle. Faint pulses of radiation brush your sensors, a rhythmic hum like a cosmic lullaby. Some regions are dense, obscuring the stars beyond, while others are so thin you see galaxies twinkling through the haze. It's serene yet chaotic, like standing in a storm that's both calm and alive with possibility. Here's a cosmic chuckle to keep things light. If you tried to take a selfie in a nebula, your camera would probably choke on all the dust. Talk about a cosmic photobomb. And good luck getting a clear shot. These clouds are so vast, you'd need a lens the size of Jupiter. Jokes aside, nebulae are more than just pretty faces. They're dynamic, shaping the universe's past and future. Star-forming nebulae, like the Orion Nebula, churn out new suns, while others, like the Crab Nebula, are the glowing scars of a star's explosive death. Each one tells a story, and you're here to read it. Let's anchor this with history. The term nebula comes from the Latin for cloud, and early astronomers like Charles Messier cataloged them in the 18th century, mistaking some for comets or galaxies. It wasn't until the 20th century, with better telescopes, that we realized nebulae were vast gas clouds, some spanning hundreds of light years. Now, here's a quirky detail. Some nebulae contain Bok globules, dense pockets of gas and dust that look like cosmic tadpoles. These oddballs can collapse to form stars, but their shapes, sometimes with tails or wispy extensions, make them look like they're swimming through the cosmos. It's like the universe decided to doodle with stardust. Now, let's stir up some academic debate. What's hiding in the darkest, densest parts of these clouds? Most scientists agree that nebulae are key to star formation. But some propose they could harbor exotic objects, like rogue planets, brown dwarfs, or even hypothetical dark stars powered by dark matter annihilation. The problem? These regions are so opaque that even our best telescopes struggle to peer inside. Every new observation, like those from the James Webb Space Telescope, brings us closer to answers, but also raises new questions. It's a cosmic game of hide and seek, and we're still learning the rules. Let's make this personal. As you drift through this nebula, you feel like an explorer in a fairy tale forest, surrounded by glowing wisps that seem to whisper secrets. The light shifts, casting shadows that look like faces or creatures, playing tricks on your mind. You're not just seeing gas and dust. You're seeing the birthplace of stars, maybe even the raw materials that formed Earth billions of years ago. The nebula's glow feels like a connection to the cosmos, a reminder that you're made of the same stuff as these clouds. It's humbling, but it also makes you feel like you belong to something vast and eternal. In today's world, nebulae are more than just cosmic eye candy. They're scientific gold mines. Telescopes like Hubble and Webb capture their beauty in stunning detail, revealing clues about star formation, chemical evolution, and even the universe's early days. In 2022, Webb's images of the Carina Nebula showed hidden star clusters and jets of gas, hinting at processes we're only beginning to understand. Nebulae are also cultural icons, inspiring art, music, and stories. Think of the pillars of creation in the Eagle Nebula. Those towering columns of gas look like a cosmic cathedral, reminding you that the universe is as much about awe as it is about science. But not all nebulae are serene. Some, like planetary nebulae, form when dying stars shed their outer layers, creating glowing shells with shapes like eyes, butterflies, or hourglasses. Others, like the Veil Nebula, are supernova remnants, stretched thin by ancient explosions. Then there are the mysterious dark nebulae, like the Horsehead Nebula, which block light rather than emit it, hiding who knows what in their depths. Each type is a puzzle piece in the universe's story, and you're piecing it together. Before we move on, let's revisit that call to action. What do you think is lurking in the darkest corners of a nebula? New stars, rogue planets, or something weirder? Drop your thoughts in the comments, and let's keep exploring the cosmic unknown. Nebulae are proof that the universe loves a good mystery, and you're part of solving it. As you glide out of this glowing cloud, Its colors linger in your vision, like a dream you're not ready to leave. But the universe has more surprises waiting. What happens when a star gets swallowed by another star, creating something truly bizarre? Let's find out. You're cruising through the galaxy, stars twinkling like distant campfires, when your sensors pick up something utterly bizarre. A star that doesn't behave like a star. It's pulsing with an odd rhythm, glowing with colors that seem wrong, like a cosmic glitch. This is no ordinary celestial body. It's a Thorne-Żytkow object, TZO. A freak of nature where one star has swallowed another, creating a hybrid so strange it feels like the universe is playing a prank. Picture a neutron star living inside the heart of a giant star, like a cosmic Russian nesting doll. You're about to dive into one of the rarest, most mind-bending objects in the cosmos, where the rules of stellar life get turned upside down. Let's set the stage. A Thorne-Żytkow object forms when a neutron star, the ultra-dense remnant of a supernova, collides with a giant star, usually a red supergiant. Instead of obliterating each other, they merge, with the neutron star sinking to the giant's core. The result is a star that looks normal on the outside but hides a secret. A neutron star at its heart, stirring up chaos. These objects are theoretical oddities, predicted in the 1970s by physicists Kip Thorne and Anna Żytkow, and only a handful of candidates have ever been spotted. They're like cosmic unicorns, rare, elusive, and almost too weird to believe. Now, let's plunge into the sensory experience. You're orbiting this TZO, and it's a visual paradox. The outer layers glow like a red supergiant should, a deep, fiery orange that bathes your ship in warmth, like standing too close to a bonfire. But something's off. The star's surface ripples with strange pulsations, as if it's struggling to contain the monster within. Your instruments detect bursts of X-rays and odd chemical signatures, hints of the neutron star's influence deep inside. If you could hear it, there'd be a low, eerie hum, like a heartbeat mixed with the groan of a machine pushed to its limits. It's beautiful, unsettling, and feels like the star is whispering, "I'm not what you think I am." Here's a cosmic chuckle to keep things light. If a Thorne-Żytkow object were a person, it'd be that friend who seems normal but has a secret double life as a rock star, or maybe a supervillain. And if you tried to visit one, your spaceship's GPS would probably throw up its hands and say, "Nope, this star's too weird for me." Jokes aside, TZOs are a cosmic paradox. They look like giant stars, but their cores behave like neutron stars, with densities so extreme that a single spoonful weighs as much as a mountain range. The neutron star's gravity and magnetic field churn the giant's interior, creating exotic fusion reactions that produce elements rarely seen in normal stars. Let's anchor this with a historical note. The concept of TZOs emerged in 1975 when Kip Thorne and Anna Żytkow published a paper theorizing these hybrid stars. It was a bold idea, blending the physics of neutron stars with the complex dynamics of stellar interiors. Decades later, in 2014, astronomers identified a possible TZO candidate, a star called HV 2112, which showed weird chemical signatures like high levels of lithium and molybdenum. Now, here's a quirky detail. TZOs might be cosmic alchemists. Their unique fusion processes could produce rare heavy elements, like rubidium or strontium, in ways no other star can. It's like the universe opened a secret chemistry lab, and TZOs are the mad scientists running it. Now, let's spark some academic debate. Are TZOs even real? Or are they just a theoretical fever dream? Some astronomers argue that HV 2112 and other candidates might be misidentified. Maybe they're just odd supergiants or binary systems faking it. Others insist the chemical anomalies are a smoking gun, proof of a neutron star's influence. The challenge is that TZOs are hard to confirm. Their neutron star cores are buried deep, invisible to most telescopes. Advanced observatories like the James Webb Space Telescope might settle the debate. But for now, it's a cosmic mystery that keeps scientists arguing late into the night. Let's make this personal. As you orbit this TZO, you feel like you're staring at a cosmic riddle. The star's glow is warm, almost inviting, but its strange pulses make your heart race with unease. You imagine the neutron star inside, spinning furiously, its gravity warping the giant's core like a black hole's less evil cousin. You're witnessing a marriage of opposites, a delicate giant and a dense gremlin, coexisting in a dance that shouldn't be possible. It's a reminder that the universe loves to break its own rules, and you're here, a tiny speck, catching it in the act. The star's light feels like a challenge, daring you to understand its secrets. In today's world, TZOs are a frontier of astrophysics. They push our understanding of stellar evolution, neutron star behavior, and even nucleosynthesis, the process that forges the elements in stars. If confirmed, TZOs could reveal how heavy elements spread through the universe, maybe even contributing to the stuff that makes up your phone or your bones. Modern telescopes and computer simulations are hunting for more candidates, but their rarity makes them a needle in a cosmic haystack. They're also a cultural spark, inspiring sci-fi writers to dream up stories of stars with hidden hearts, proof that the universe is as poetic as it is scientific. But TZOs aren't just about science. They're about wonder. Their existence suggests that even in a universe full of stars, there's room for the bizarre. They might not last long. Some models suggest the neutron star could destabilize the giant, leading to a supernova or even a black hole. Imagine a star that's both a cradle and a coffin, living a fleeting, chaotic life before collapsing into something even stranger. It's a cosmic soap opera, and you've got a front row seat. Before we move on, let's revisit that call to action. Do you think Thorne-Żytkow objects are real? Or are they just a cosmic mirage? What could their weird chemistry tell us about the universe? Drop your thoughts in the comments, and let's keep the cosmic detective work going. TZOs are proof that the universe loves a good plot twist. As you pull away from this enigmatic star, its strange glow lingers in your mind, like a puzzle you're not quite ready to solve. But the universe has more oddities in store. What happens when entire galaxies break the mold and become cosmic freaks? Let's find out. You're soaring through the cosmos, stars streaking past like fireflies, when a massive shape looms into view. A galaxy, but not the spiral beauty you're used to. This one's a mess, twisted and warped, like a cosmic car wreck frozen in time. These are strange galaxies, the misfits of the universe, with shapes and behaviors that defy everything you thought you knew about the cosmos. They're not just swirling disks of stars, they're chaotic, violent, and sometimes downright monstrous. Buckle up, because you're about to meet the weirdest galaxies in the universe, where the rules of cosmic architecture get thrown out the window. Picture a galaxy as a city of stars, billions of them, orbiting in harmony around a central hub. Most galaxies, like our Milky Way, are neat spirals or smooth ellipticals, their stars dancing in orderly patterns. But strange galaxies? They're the rebels. Some are smashed together, their arms tangled like cosmic wrestlers. Others are stretched into bizarre shapes, rings, lenses, or even jellyfish-like tendrils. These oddballs form through collisions, gravitational tugs, or internal chaos, creating structures so wild they look like the universe got a little too creative. You're not just looking at a galaxy. You're witnessing a cosmic crime scene, alive with drama. Let's dive into the sensory overload. You're floating near a peculiar galaxy, and it's a visual riot. Stars glow in chaotic clumps, some blazing blue, others fading red, scattered like confetti after a galactic party. Gas clouds twist and spiral, lit by violent starbursts that flash like distant lightning. Your ship vibrates faintly, picking up gravitational waves from the galaxy's turbulent past. If you could hear it, there'd be a low rumble, like a storm growling across light years, mixed with sharp cracks from exploding stars. The scene feels alive, restless, as if the galaxy is still reeling from whatever cosmic catastrophe shaped it. Here's a cosmic chuckle to lighten the mood. If this galaxy were a painting, it'd be the kind that makes art critics argue. Beautiful chaos or just a hot mess? And if you tried to navigate it, your starship's GPS would probably just say, "Good luck, buddy." Jokes aside, strange galaxies are more than just eye candy. They're evidence of the universe's violent history. Take ring galaxies, for example, formed when one galaxy punches through another like a cosmic bullet, creating a shockwave that sculpts a glowing ring of stars. Or consider irregular galaxies, like the Large Magellanic Cloud, which look like they forgot how to be organized, their stars and gas scattered in a glorious mess. Let's anchor this with a historical note. Galaxies were first recognized as distinct island universes in the 1920s, thanks to Edwin Hubble, who showed that fuzzy patches in the sky were entire star systems, not just nebula. His work redefined our view of the cosmos. Now, here's a quirky detail. Some strange galaxies, called green pea galaxies, are tiny but glow with intense green light from oxygen-rich gas, making them look like cosmic emeralds. Discovered by citizen scientists in 2007 through the Galaxy Zoo project, these pint-sized powerhouses churn out stars at a frantic pace, defying their small size with outsized energy. Now, let's stir up some academic debate. What causes a galaxy to go rogue? Most astronomers point to gravitational interactions, like collisions or near misses, that reshape galaxies over millions of years. But some argue that internal processes, like supermassive black holes or bursts of star formation, could play a bigger role than we think. Could dark matter, the invisible glue holding galaxies together, also twist their shapes in unexpected ways? Observations from telescopes like the Hubble and ALMA are fueling the debate. But each new image of a weird galaxy adds more questions than answers. It's like the universe is daring us to figure out its playbook. Let's make this personal. As you drift near this chaotic galaxy, you feel like a speck in a cosmic storm. The stars whirl around you, some newborn, others dying in brilliant supernovae. You imagine the collisions that shape this mess. Galaxies crashing like titans, their stars flung into new orbits. It's humbling, but it also sparks a sense of wonder. You're part of this story, connected to the same forces that sculpted these galactic oddballs. The light hitting your eyes left those stars millions of years ago, when your ancestors were still figuring out fire. It's a reminder that you're not just in the universe, you're of it. In today's world, strange galaxies are a hot topic. Telescopes like the James Webb Space Telescope are capturing images of galaxies so early in cosmic history that they look nothing like the orderly spirals we know. In 2023, Webb spotted galaxies with bizarre shapes. Some elongated like cigars, others clumped like cosmic popcorn, hinting at a chaotic young universe. These discoveries are rewriting our understanding of galaxy formation, showing that the cosmos was a wilder place than we thought. Strange galaxies also inspire us beyond science. Think of the swirling, surreal art of Van Gogh, whose Starry Night feels like a nod to these cosmic misfits. But the weirdness doesn't stop at shapes. Some galaxies, like active ones, have supermassive black holes blasting out jets of plasma that stretch across millions of light years. Others, called jellyfish galaxies, have tentacles of gas stripped away by their motion through dense cosmic environments. Then there are polar ring galaxies, with rings of stars orbiting at odd angles, like a cosmic hula hoop gone rogue. Each one is a testament to the universe's creativity, a reminder that even galaxies can break the mold. Before we move on, let's revisit that call to action. What do you think makes a galaxy go weird? Collisions, black holes, or maybe some unknown cosmic force? Drop your thoughts in the comments, and let's keep exploring the universe's wild side. Strange galaxies show us that the cosmos is never predictable. As you pull away from this galactic chaos, its twisted shapes linger in your mind, like a dream you can't shake. But the universe has one last trick up its sleeve. What's your place in this cosmic zoo of wonders? Let's find out. You're floating in the vastness of space. Your spaceship a tiny speck against a backdrop of stars, nebulae, and cosmic oddities that stretch beyond imagination. You've just journeyed through a gallery of the universe's strangest creations. Quasars blazing brighter than galaxies, black holes twisting reality, neutron stars denser than mountains, magnetars with magnetic fields that could fry your tech, nebulae hiding cosmic secrets. Thorne-Żytkow objects defying stellar logic, and galaxies warped into chaotic masterpieces. Now, as you pause to take it all in, a question lingers. In this wild, infinite cosmos, where do you fit? What's your role in a universe that's both beautiful and bizarre, vast and indifferent, yet somehow feels like home? Let's take a moment to breathe in the cosmic scale. You're surrounded by a universe that's 13.8 billion years old, stretching billions of light years in every direction. The light from the quasars you've seen left their sources when Earth was just a molten rock. Yet here you are, catching their glow with your own eyes, or at least your ship's sensors. The strange galaxies you've explored were shaped by collisions that began before life even sparked on our planet. These cosmic wonders aren't just out there. They're part of a story that includes you. You're not just an observer. You're a product of this universe, made from the same stardust forged in the hearts of ancient stars. Feel the weight of that connection. The carbon in your bones, the oxygen in your lungs, the iron in your blood. All of it was cooked in stellar furnaces billions of years ago. Picture a supernova exploding, its shock waves scattering elements across the cosmos, eventually coalescing into a blue-green planet where you now stand, think, and dream. The neutron stars and nebulae you've encountered aren't distant abstractions. They're your cosmic ancestors. As you gaze out at the twinkling void, it's like looking at a family tree that spans light years, with every strange object a branch that led to you. Here's a little cosmic humor to keep it light. If the universe threw a family reunion, you'd probably be the awkward cousin who showed up late with a smartphone and a coffee addiction. And good luck explaining to a Magnetar why you missed the last billion years of cosmic drama. Jokes aside, this connection to the cosmos is profound. It's easy to feel small when you're staring at a quasar that outshines entire galaxies or a galaxy twisted by forces beyond comprehension. But small doesn't mean insignificant. Your ability to ponder these mysteries, to ask questions and seek answers, makes you a unique part of the universe's story. Let's ground this with a historical touch. Centuries ago, Galileo turned his telescope to the skies and saw Jupiter's moons, proving that Earth wasn't the center of everything. That moment sparked a revolution in how we see ourselves. A shift from being the universe's focal point to being curious explorers in a vast cosmic sea. Now, here's a quirky detail. The universe is so big that the light we see from distant objects is a time capsule. When you look at a strange galaxy 10 billion light-years away, you're seeing it as it was when the universe was young, long before humans existed. It's like getting a postcard from the cosmos, stamped with a message from billions of years ago. Now, let's stir up some academic debate. What's the ultimate purpose of studying these cosmic oddities? Some scientists argue it's about understanding the universe's mechanics, how stars form, how galaxies collide, how black holes bend space-time. Others say it's philosophical, a quest to grasp our place in the grand scheme. Are we here to decode the universe's laws, or to marvel at its mysteries and find meaning in our existence? Every new discovery, from a magnetar's burst to a nebula's glow, fuels this debate, pushing us to ask not just how, but why. It's a question as old as humanity, and you're part of the conversation. Let's make this personal. As you float in your spaceship, the stars feel like they're watching you back. The universe is vast, but it's not cold or empty. It's alive with stories, from the pulsing heart of a Thorne-Żytkow object to the chaotic dance of a strange galaxy. You feel a tug in your chest, a mix of awe and curiosity. These objects aren't just scientific puzzles. They're invitations to wonder, to imagine, to explore. You're not just a speck in the cosmos. You're a mind capable of grasping its wonders, a spark of consciousness in a universe that's been shaping itself for eons. That's your superpower, the ability to look at the stars and ask, what's next? In today's world, this cosmic curiosity drives us forward. Telescopes like the James Webb Space Telescope are revealing galaxies and nebulae in unprecedented detail, while experiments like LIGO catch ripples from colliding neutron stars. In 2024, scientists discovered a galaxy with a shape so bizarre it challenged models of cosmic evolution, sparking new theories about dark matter's role. These discoveries aren't just for astronomers. They're for you, too. They inspire art, fuel sci-fi, and remind us that the universe is a playground for imagination. Your favorite movie, your late-night stargazing, even your daydreams about aliens, all trace back to the same cosmic wonders you've just explored. But it's more than science or stories. These strange objects challenge you to think bigger. Quasars show you the universe's raw power. Black holes test your grasp of reality. Nebulae remind you of creation's beauty. They're not just out there. They're part of you. Every question you ask, every theory you ponder, connects you to the cosmos in a way that's uniquely human. The universe doesn't care about your to-do list or your Wi-Fi signal, but it's given you the tools to understand it, to marvel at it, and to share that wonder with others. So, here's the final call to action. In a universe filled with quasars, magnetars, and strange galaxies, what's your place? Are you a curious explorer, a dreamer, or maybe a cosmic detective chasing the next big mystery? Drop your thoughts in the comments, and let's keep this conversation going. The universe is vast, weird, and wonderful, and you're right in the middle of it. As you steer your ship toward the next adventure, the stars seem to wink, as if they know something you don't. The universe is full of surprises, and you're part of its unfolding story. Keep looking up, keep asking questions, and keep exploring. The cosmos is waiting.